They told you we found 7 Earth-like planets around TRAPPIST-1. They told you K2-18b might harbour life. They told you we are close to answering if we're alone. Every single one of those statements is a lie. Right now, astronomers are quietly walking back decades of exoplanet hype, and what they are discovering is far more disturbing than you can imagine. Over 50% of confirmed planets turned out to be false positives. The most hyped habitable worlds have no atmospheres. And the detection methods we use are so biased, we might have missed entire populations of planets. If you want to understand what is really happening in the search for alien worlds, before the next headline deceives you, you need to be subscribed to this channel. Right now, somewhere in a university press release, a planet is being called Earth-like. Right now, some science communicator is telling you we might have found life. Right now, a headline screams that we have discovered a habitable world 40 light years away. And right now, astronomers who actually work on these discoveries are quietly shaking their heads because they know something you do not. The exoplanet revolution has given us over 6,000 confirmed worlds beyond our solar system. But alongside those discoveries came something else. Lies. Not malicious lies, but lies born from excitement, from misunderstanding, from the desperate human need to believe we are not alone. Today, we're going to dismantle 33 of the biggest falsehoods, misconceptions, and outright fabrications that have shaped how you think about planets around other stars. Buckle up, this is going to hurt. The first lie is perhaps the most fundamental. You have been told that if a planet sits in the habitable zone, it might harbour life. This is the Goldilocks zone, the region around a star where temperatures are just right for liquid water. And you have been told this so many times that it has become gospel. Here is the problem. The habitable zone does not mean habitable. Let me say that again. Being in the habitable zone does not make a planet capable of supporting life. Our own moon sits squarely in the habitable zone. Same distance from the sun as Earth. 0 life, 0 atmosphere, 0 chance. The habitable zone is a crude, oversimplified concept that only accounts for one variable: the amount of radiation a planet receives from its star. It ignores atmospheric composition. It ignores magnetic fields. It ignores plate tectonics. It ignores nitrogen abundance. It ignores whether the planet even has an atmosphere at all. Venus also sits near the edge of our habitable zone. Its surface temperature is hot enough to melt lead. Its atmospheric pressure would crush you like a soda can. This is your habitable zone candidate. Scientists at MIT and the University of Washington have published studies showing that the habitable zone is far more complex than a simple temperature calculation. A planet needs nitrogen to maintain, atmospheric pressure. It needs a magnetic field to protect against stellar radiation. It needs tectonic activity to recycle nutrients. Remove any one of these factors, and your habitable zone planet becomes a lifeless rock. But we will get back to how bad the situation really is in a minute. The second lie is about the most hyped planetary system of the past decade. TRAPPIST-1. You remember this one, 2017. 7 Earth-sized planets, 3 in the habitable zone. The media lost their minds. This was it. This was where we would find life. Except we will not. In 2024 and 2025, the James Webb Space Telescope turned its instruments toward TRAPPIST-1. What it found was devastation. TRAPPIST-1b has no substantial atmosphere. TRAPPIST-1c has no substantial atmosphere. TRAPPIST-1d, sitting right on the inner edge of the habitable zone, shows no sign of water, methane or carbon dioxide in its air. No Earth-like atmosphere detected. The outer planets remain under investigation, but here is what nobody told you when TRAPPIST-1 was announced. Red dwarfs are violent. TRAPPIST-1 flares every couple of days, between 4 and 6 superflares every year. These are not gentle solar flares. These are atmosphere-stripping, sterilizing blasts of X-rays and ultraviolet radiation. Computer simulations published in Astronomy and Astrophysics show that over billions of years, these flares should have completely stripped away any atmospheres the TRAPPIST-1 planets might have once had. The inner planets never stood a chance. The outer planets are questionable. And yet, when TRAPPIST-1 was discovered, the press releases spoke of Earth-like worlds and possibilities for life. That was lie number 2. The third lie involves a planet called K2-18b. In late 2023, astronomers announced they had detected dimethyl sulfide in the atmosphere of this exoplanet. On Earth, dimethyl sulfide is only produced by life, specifically by phytoplankton in the oceans. The implications were staggering. This was potentially the first biosignature detected on an exoplanet. NASA and the science media went wild. We might have found evidence of life on another planet. Then came 2024. A new study published in Astrophysical Journal Letters looked at the same data. Their conclusion was blunt. There is no dimethyl sulfide on K2-18b. The original detection was incorrect. The planet gets almost the same amount of solar radiation as Earth, but that detection you heard about everywhere, the one that suggested life, it was wrong. This was not a case of fraud or incompetence. It was a case of pushing data to its limits and seeing patterns that were not there. But the damage was done. Millions of people believe we detected signs of life on K2-18b. We did not. This is lie number 3, and it reveals something critical. The desire to find life is so strong that we see it even when it is not there. Now let me tell you about lie number 4. You have been told that over 6,000 exoplanets have been confirmed. This is technically true, but what you have not been told is that a huge fraction of the original candidates turned out to be false positives. Researchers using the SOFI spectrograph followed up on 129 giant exoplanet candidates detected by the Kepler Space Telescope. Massive worlds, easy to detect, the kind of planet that should be simple to confirm. The results shocked everyone. 52% were not planets. More than half were false positives. Eclipsing binary stars, stellar activity, noise in the data. These false positives were not limited to giant planets. Smaller planet candidates also fell victim. KOI 1686.01 was considered potentially habitable for years until NASA declared it a false positive in 2015. Dozens of other Kepler objects of interest turned out to be nothing. Stellar variability mimicking planetary transits. Magnetic activity producing radial velocity signals that looked like orbiting planets. In fact, researchers publishing in the American Astronomical Society found that stellar activity around red dwarfs is one of the leading causes of false positive exoplanet detections. A star's magnetic field creates variations that look exactly like a planet tugging on the star. The problem is so pervasive that astronomers now require multiple lines of evidence before confirming a planet. But in the early days of exoplanet discovery, many candidates were announced prematurely, and even today the Exoplanet Archive regularly updates the status of planets to false positive. Just this year, multiple planets had their status changed because new data revealed they were either brown dwarfs, too massive to be planets, or simply did not exist. How many of the 6,000 confirmed exoplanets are real? Probably most of them, but the number is definitely lower than you have been told. Lie number 5 is about a specific detection that shaped the field. In the 1990s, astronomers announced the discovery of a planet orbiting the star HD 114762. This was one of the earliest exoplanet claims. The planet was massive, about 11 times the mass of Jupiter. For years it appeared in exoplanet catalogues. Then, in 2019, follow-up observations revealed the truth. HD 114762b is not a planet. It is a brown dwarf or possibly even a red dwarf star. It was never a planet to begin with. This was not the only time this happened. Gamma Cephei b, claimed in the 1980s, was rejected, then confirmed again in 2002. Alpha Centauri b, announced in 2012 as the nearest exoplanet to Earth, was later found to be an artifact in the data. It does not exist. These are not minor errors. These were headline-making discoveries that shaped public perception of exoplanets. And they were wrong. Lie number 6 involves the term super-Earth. When you hear super-Earth, you probably think of a larger version of our planet. Rocky surface, maybe some oceans, possibly habitable. That is not what super-Earth means. The term super-Earth refers only to mass. Any planet between roughly 1 and 10 Earth masses gets called a super-Earth. It says nothing about composition, nothing about atmosphere, nothing about habitability. Many so-called super-Earths are actually mini-Neptunes, small gas giants with thick hydrogen and helium atmospheres. Others might be water worlds, planets where water makes up a huge fraction of their mass. Some could be carbon-rich worlds, completely unlike Earth. The term super-Earth is marketing. It makes planets sound Earth-like when they are not. Researchers have tried to introduce better terminology: mini-Neptune, sub-Neptune, ocean planet, water world, gas dwarf. But super-Earth stuck because it sounds exciting, and that is a lie number 6. The name itself is misleading. Let me tell you about lie number 7. Scientists discovered 7 Earth-sized rocky planets around TRAPPIST-1, and 3 or 4 are in the habitable zone. That is what you were told. Here is what is actually true. The planets are approximately Earth-sized, but size alone tells us almost nothing. TRAPPIST 1e, F, and G are in a narrow habitable zone around a red dwarf star. But being in the zone means nothing without atmospheres, and we have already established that red dwarf flares likely stripped those atmospheres away. Recent studies suggest that the best-case scenario for TRAPPIST-1 is that maybe, possibly, the outer planets might have retained thin atmospheres. But even that is uncertain. What about the rocky composition? Well, density measurements suggest rock and iron similar to Earth, but density alone does not tell us about surface conditions. It does not tell us about volcanic activity, tectonic processes, or any of the factors that make Earth habitable. TRAPPIST-1 was marketed as 7 Earth-like worlds with multiple planets in the habitable zone. The reality is 7 roughly Earth-sized objects that are probably atmosphereless, tidally locked, and blasted by radiation. That is not Earth-like. That is Venus at best, Mercury at worst. Lie number 8 is about detection methods. You have been told that astronomers can detect exoplanets using the transit method and radial velocity. Both are true, but what you have not been told is that these methods are biased, heavily biased. The transit method can only detect planets that pass directly between us and their star. If the planet's orbit is tilted even slightly, we miss it entirely, and even when planets do transit, we can only detect them if they are close enough to their star to transit frequently. A planet like Jupiter, taking 12 years to orbit, would require decades of continuous observation to confirm. We would miss it. The radial velocity method detects the wobble a planet causes in its star, but massive planets close to their stars cause bigger wobbles. Small planets far from there. Stars cause wobbles so tiny they drown in noise. So what does this mean? It means we have found thousands of hot Jupiters, massive gas giants orbiting insanely close to their stars, not because they are common, but because they are easy to find. It means we have found hundreds of super-Earths orbiting close to red dwarfs, not necessarily because they are abundant, but because red dwarfs are dim and close planets create detectable signals. It means the exoplanet population we have discovered is not representative of what is actually out there. We have found the loud, obvious planets, the quiet ones, the ones like Earth, orbiting sun-like stars at Earth-like distances. Those are almost invisible to us. Our detection methods have created a false picture of the universe. That is lie number 8. Now we get to lie number 9, the most common type of planet in the galaxy. Astronomers tell you that super-Earths and mini-Neptunes are everywhere. They are the most common planets we have found. 75% of detected exoplanets fall into this size category. Planets with radii between 1.5 and 4 times Earth. And here is the kicker. Our solar system has 0 of them. Not a single planet in our solar system falls into the most common planetary category in the galaxy. How is that possible? This is one of the great mysteries of planetary science. If super-Earths and mini-Neptunes are so common, why does our solar system lack them entirely? Did Jupiter's formation prevent them from forming here? Did they form and then get destroyed? Or is our detection bias so severe that we are drastically overestimating how common these planets really are? Nobody knows. But the disconnect is staggering. We tell ourselves we understand planetary formation based on our solar system. Then we look at other stars and find that our solar system is the weird one. That is lie number 9, the idea that we understand what is normal. Lie number 10 is about something called the radius gap, also known as the Fulton gap. Between 1.5 and 2 Earth radii, there is a strange scarcity of planets. Not 0 planets, but far fewer than you would expect. Why? 2 competing theories. One says planets form with thick hydrogen atmospheres, and if they are too close to their star, photoevaporation strips away the atmosphere, leaving behind a smaller rocky core. These cores fall below the gap. Planets that keep their atmospheres stay above it. The second theory says planets form as either rocky super-Earths or gas-rich mini-Neptunes from the start. There is no transition. They are born into different populations. Recent research published in Nature Astronomy supports a hybrid explanation. Some planets in the gap are water-rich worlds that migrated inward from beyond the ice line. Others are rocky cores whose atmospheres were blown away. The radius gap is not one thing. It is multiple processes creating the same observational feature. But here is the lie. When scientists talk about the radius gap, they present it as understood. It is not. The gap is one of the biggest unsolved puzzles in exoplanet science, and every new discovery seems to complicate the picture rather than clarify it. Let me tell you about lie number 11. Hot Jupiters. These are gas giants orbiting ridiculously close to their stars. Closer than Mercury is to our Sun. They complete orbits in days. Their atmospheres are thousands of degrees. They should not exist. Gas giants need to form far from their stars, beyond the ice line, where temperatures are low enough for volatile gases to condense. So how did hot Jupiters get so close? For decades, the accepted answer was migration. Planets form far out, then migrate inward through interactions with a protoplanetary disk. Nice, clean, simple. Except it is not that simple. In 2016, astronomers studying the planet HD 80606b found that disk migration could not explain its orbit. The planet is on a highly eccentric trajectory, swinging close to its star and then far away. This suggested a different mechanism, high eccentricity tidal migration. In this scenario, gravitational interactions with another planet or a companion star throw the gas giant onto a wildly elliptical orbit. Each time it swings close to its star, tidal forces sap energy from its orbit. Over hundreds of millions of years, the orbit circularizes, and you get a hot Jupiter. Then in 2024, researchers discovered another planet in the process of this migration. TSC 24.92530b has an orbital eccentricity of 0.94. It is currently undergoing the process. But here is the twist. Some hot Jupiters show no sign of migration at all. Young hot Jupiters exist around stars that are only a few million years old. They have not had time to migrate. This implies a third formation mechanism, in situ formation. The planet forms close to the star from the start. So which is it? Disk migration, tidal migration, or in situ formation? The answer is probably all three. But the lie is that we understood how hot Jupiters form. We do not. Every new discovery complicates the picture. Lie number 12 is about the Earth Similarity Index. This is a number between 0 and 1 that measures how similar a planet is to Earth. 1 is identical to Earth. 0 is completely different. Sounds useful, right? Here is the problem. The Earth Similarity Index is based on radius, density, escape velocity, and surface temperature. That is it. 4 parameters. And it turns out you can get a high Earth Similarity Index score while being absolutely nothing like Earth. Venus scores 0.9. Let me repeat that. Venus, with its crushing atmospheric pressure, sulfuric acid clouds, and surface temperature of 470 degrees Celsius, scores a 0.9 on the Earth Similarity Index. Why? Because it is similar in size and density to Earth. The ESI ignores atmosphere, magnetic field, rotation rate, axial tilt, orbital dynamics, and every other factor that makes Earth habitable. A planet could score high on the ESI and still be a hellscape, or it could score low and be a paradise. The ESI is a marketing tool. It gives the illusion of scientific precision while providing almost no useful information. But it gets cited in press releases and news articles as if it means something. That is lie number 12. Now let us talk about lie number 13. Astronomers discovered oxygen in an exoplanet's atmosphere, a sign of life. This has not happened yet, but it is coming. And when it does, you need to know the truth. Oxygen can be produced without life. On Earth, nearly all atmospheric oxygen comes from photosynthesis. Plants, algae, and cyanobacteria split water molecules and release oxygen. This makes oxygen a strong biosignature candidate. But research from NASA's Virtual Planetary Laboratory has shown that some planets can generate oxygen abiotically, through non-living processes. For example, if a planet is too close to its star, intense ultraviolet radiation can split water molecules in the upper atmosphere. Hydrogen escapes to space, oxygen accumulates, No life required. Similarly, carbon dioxide can be photodissociated into carbon monoxide and oxygen. Volcanic outgassing can release oxygen. Even certain chemical reactions in the crust can produce oxygen over geologic timescales. The term for this is biosignature imposters, molecules that look like signs of life but are not. Scientists studying this problem have concluded that detecting oxygen alone is not enough. You need to detect oxygen in combination with other gases like methane, in proportions that cannot be explained by non-biological chemistry. You need to rule out alternative explanations, and even then, you cannot be certain. The universe is full of weird chemistry we do not understand. That is lie number 13. Oxygen equals life. It does not. Let me tell you about lie number 14. Scientists found a planet that should not exist. This headline appeared in 2024 when astronomers announced the discovery of 8 Ursae Minoris b. This planet orbits a red giant star. As stars age and become red giants, they expand dramatically. This star should have engulfed and destroyed any planets orbiting close to it. But 8 Ursae Minoris b is still there, in a stable, nearly circular orbit. The discovery was framed as something that defies our understanding of planetary evolution. Except it does not. Planetary survival around evolving stars is complicated, but it is not impossible. The star's mass loss during its red giant phase can cause planetary orbits to expand. Tidal interactions can stabilize orbits. Planets can survive engulfment if they have enough mass. What seemed impossible is just unlikely. The problem is that the framing, the planet that should not exist, makes it sound like our theories are wrong. They are not wrong. They are incomplete. Every anomaly teaches us something new, but anomalies are not evidence that everything we know is false. That is lie number 14. Anomalies mean our understanding is broken. No, anomalies mean our understanding is evolving. Lie number 15 involves Proxima Centauri b. This is the nearest confirmed exoplanet to Earth, orbiting Proxima Centauri just 4 light-years away. It sits in the habitable zone. It is roughly Earth mass. The media went insane when it was announced. Our nearest neighbour might be habitable. Here is what they did not tell you. Proxima Centauri is a red dwarf, an incredibly violent red dwarf. It flares constantly. In 2017, astronomers observed a superflare from Proxima Centauri that increased the star's brightness by 1,000 times in the ultraviolet. For 10 seconds, Proxima Centauri b was bathed in radiation, equivalent to standing directly under an unshielded nuclear reactor. Models suggest that planets around Proxima Centauri receive 10 times more X-ray radiation than Earth receives from the Sun. Over billions of years, this radiation would strip away any atmosphere. It would sterilize the surface. It would break apart water molecules and blast the hydrogen into space. Proxima Centauri b might technically be in the habitable zone, but it is almost certainly not habitable, and yet every few years, another study comes out suggesting we should look for biosignatures there. We should send probes. We should study it as a potential home for humanity. This is wishful thinking masquerading as science. Proxima Centauri b is not a second Earth. It is a radiation-blasted rock. That is lie number 15. Let us talk about lie number 16. Water worlds are a good place to look for life. If a planet has vast oceans covering its entire surface, that should increase the chances of life, right? Not necessarily. Research published in Nature Geoscience suggests that water worlds might be terrible for life. Here is why. On Earth, the water cycle interacts with the rock cycle. Plate tectonics drags carbon into the mantle, then volcanic eruptions release it back into the atmosphere. This regulates Earth's climate over geologic timescales. A planet covered entirely in water would not have this feedback loop. The rock would be buried under kilometers of ocean. No plate tectonics, no carbon cycle, no climate regulation. Worse, if the ocean is deep enough, the pressure at the bottom would create a layer of high-pressure ice. This ice layer would prevent heat from the planet's interior from reaching the ocean. The ocean would be cold, stagnant, isolated from the geochemical processes that drive life on Earth. Some scientists even argue that too much water is as bad as too little. Earth has the right amount of water because most of it is locked in the mantle. If all of Earth's mantle water were on the surface, we would be a water world, and life as we know it might not have emerged. So when you hear about a planet being an ocean world, do not assume that is good news. It might be the worst possible scenario. That is lie number 16. Now let's get into lie number 17, the galactic habitable zone. You have probably heard of the circumstellar habitable zone, the region around a star where liquid water can exist. But there is also a galactic habitable zone, the region of the galaxy where stars are most likely to host habitable planets. Too close to the galactic centre, and you get too much radiation from supernovae, black holes and dense stellar populations. Too far from the centre, and you do not have enough heavy elements to form rocky planets. The galactic habitable zone is supposed to be a ring where conditions are just right. Here is the problem. The galactic habitable zone is speculative at best. We have no observational evidence that planets near the galactic centre are less likely to host life. We have no evidence that planets in the galactic outskirts cannot support life. The entire concept is based on models and assumptions. It sounds scientific. It gives the appearance of narrowing down where we should look for life. But it is built on a foundation of uncertainty, and yet it gets cited constantly as if it is established fact. That is lie number 17. Lie number 18 is about metallicity. In astronomy, metallicity refers to the abundance of elements heavier than hydrogen and helium. Stars with high metallicity are more likely to have planets. This is true, but here is the lie. High metallicity stars are more likely to have large planets, gas giants. The correlation between metallicity and small rocky planets is much weaker. Studies have shown that low metallicity stars can and do host terrestrial planets. The idea that we need to focus on high metallicity stars to find Earth-like worlds is not supported by the data. But the metallicity paradigm is so ingrained in exoplanet science that it shapes where we look and what we prioritize. We are biasing our search based on an assumption that might be wrong. That is lie number 18. Now we get to lie number 19. Rogue planets. Free-floating planets not bound to any star. For years, astronomers speculated that rogue planets might be common. Some estimates suggested there could be billions of them in the Milky Way. These planets would be ejected from their original star systems through gravitational interactions. They would wander the galaxy alone, dark, cold, lifeless. Except maybe not lifeless. Some scientists proposed that rogue planets could retain internal heat from their formation. Tidal heating from a moon could generate energy. A thick atmosphere could trap heat. These rogue planets might even have subsurface oceans. They could host life in complete darkness. This is a beautiful idea. But recent surveys have found far fewer rogue planets than expected. The estimates of billions of rogue planets were based on extrapolations from a handful of detections. When astronomers actually went looking for them with advanced instruments, they found that rogue planets are much rarer than predicted. They exist, but they are not the dominant planetary population some scientists hoped for. The idea of widespread rogue planet habitability was always speculative. It was never based on solid evidence, but it captured imaginations and it got repeated as if it were fact. That is lie number 19. Let me tell you about lie number 20. Tidal locking is bad for habitability. Many exoplanets orbit their stars so closely that they become tidally locked. One side always faces the star, one side always faces away. The day side is scorching, the night side is freezing. This seems incompatible with life. But computer models have shown that tidal locking does not necessarily make a planet uninhabitable. If the planet has an atmosphere, winds can redistribute heat from the day side to the night side. The terminator, the boundary between day and night, could have moderate temperatures. A thick atmosphere could even create a habitable zone on the night side, powered by geothermal heat rather than starlight. Tidally locked planets are different from Earth, but different does not mean dead. Some of the most promising habitable zone candidates, including Proxima Centauri b and the TRAPPIST-1 planets, are tidally locked. We cannot dismiss them just because they are weird. That is lie number 20. Tidal locking equals death. Lie number 21 involves direct imaging. You have seen those pictures of exoplanets, beautiful images of distant worlds captured by telescopes. These images are impressive, but they are also misleading. Direct imaging works by blocking out the light of the star and capturing the faint glow of the planet itself. This only works for planets that are very large, very far from their star, and very young. Young planets are still hot from their formation, so they glow in infrared. Massive planets are bright enough to detect despite being billions of times fainter than their star. Small, old, Cool planets like Earth cannot be directly imaged with current technology. Not around sun-like stars, not at Earth-like distances. Those beautiful images you have seen are almost all gas giants. When we do finally image an Earth-like planet, it will probably look like a single pixel, a pale blue dot. That is lie number 21. The idea that we can take pictures of Earth-like exoplanets. We cannot, not yet. Let us talk about lie number 22. Scientists found Earth 2.0. This phrase gets thrown around constantly. Every time a new potentially habitable exoplanet is discovered, someone calls it Earth 2.0. Kepler 452b, Kepler 22b, Proxima Centauri b, TRAPPIST 1e. The list goes on. Here is the truth. None of these planets are Earth 2.0, not even close. Kepler 452b is 60% larger than Earth. We do not know its mass. We do not know its composition. It could be a mini Neptune. Kepler 22b is 2.4 times Earth's size. Almost certainly not. Rocky. Proxima Centauri b is radiation blasted. TRAPPIST 1e probably has no atmosphere. Earth 2.0 does not exist in our data. The closest thing we have found to Earth is Earth. That is lie number 22. Now we get to lie number 23. Atmospheric biosignatures will prove the existence of alien life. The James Webb Space Telescope can analyze exoplanet atmospheres. If we detect oxygen, methane, and other gases in the right proportions, we will have found life. This is the dream. The reality is far more complicated. As we discussed earlier, oxygen can be abiotic. Methane can be abiotic. Even combinations of gases can potentially be explained by geology and photochemistry. But it gets worse. Atmospheres are three-dimensional. Clouds can obscure molecular signatures. High-altitude hazes can block the light we need to analyze. Stellar contamination, where star spots and stellar activity interfere with measurements, can create false signals. The James Webb Space Telescope is powerful, but it is not magic. Atmospheric characterization is hard. Even if we detect something interesting, proving it is biological will require decades of follow-up observations and theoretical work. The idea that JWST will quickly confirm alien life is a fantasy. That is lie number 23. Let me tell you about lie number 24, the mediocrity principle. This is the idea that Earth is not special. There is nothing unique about our planet, our star, or our location in the galaxy. If Earth is not special, then Earth-like planets must be common. And if Earth-like planets are common, then life must be common. This principle has driven astrobiology for decades. Here is the problem. Earth might actually be special. Our moon is unusually large, stabilizing Earth's axial tilt. Our solar system has Jupiter, which shields the inner planets from comet impacts. Our sun is metal-rich, which may have been necessary for forming rocky planets. Earth's plate tectonics might be rare. Our magnetic field might be unusually strong. Every time we look closely, we find another way that Earth is not average. This does not mean life is rare, but it does mean the mediocrity principle might be wrong. And if it is wrong, then our assumptions about the prevalence of habitable planets are built on sand. That is lie number 24. Lie number 25 is about the Fermi paradox. Where are all the aliens? If planets are common and life is common, then intelligent life should be common. And if intelligent life is common, then we should see evidence of it. The fact that we do not see evidence is called the Fermi paradox. The paradox assumes that our understanding of exoplanets is correct. It assumes habitable planets are common. It assumes life arises easily. It assumes intelligence is a likely outcome. But every one of those assumptions could be wrong. If habitable planets are rare, if life is hard to start, if intelligence is a fluke, then there is no paradox. The universe is silent because we are alone, or nearly alone. The Fermi paradox is not a paradox. It is an argument based on assumptions we are not certain about. That is lie number 25. Now let us discuss lie number 26. Mini-Neptunes are just like Neptune. The name implies similarity. Neptune is an ice giant with a small rocky core, a thick mantle of water, ammonia and methane ices, and a hydrogen-helium atmosphere. Mini-Neptunes are smaller versions of this, right? Wrong. Mini-Neptunes are a catch-all category for planets between 2 and 4 Earth radii. Some might resemble Neptune. Others might be water worlds with no hydrogen atmosphere at all. Some might have rocky cores with massive hydrogen envelopes. Others might be puffy planets with almost no core. The diversity within the mini-Neptune category is staggering, but the name makes them all sound the same. This is not just semantics, it is leading to real confusion in the literature. Scientists studying mini-Neptunes are often talking about completely different types of objects. That is lie number 26. Let me tell you about lie number 27. We have discovered planets with 2 suns. This sounds like science fiction, but it is true. Circumbinary planets orbit around binary star systems. The planet has 2 suns in its sky. Tatooine from Star Wars was a circumbinary planet. We have found real ones: Kepler 16b, Kepler 47c, Tor 138b. These are amazing discoveries, but the lie is in how they are presented. You hear 2 suns and you think double the energy, double the heat, maybe even better chances for life. Not quite. In most circumbinary systems, the 2 stars are close together, and the planet orbits far away. From the planet's surface, the 2 stars appear close together in the sky, almost like a single bright object. There is no double sunset like in Star Wars, and because the planet needs to orbit far from the binary pair to remain stable, it is usually cold, very cold. Most circumbinary planets we have found are frozen worlds. The romantic image of a desert planet with twin suns does not match reality. That is lie number 27. Lie number 28 involves something called pulsars. Pulsars are rapidly spinning neutron stars that emit beams of radiation. In 1992, astronomers discovered planets orbiting the pulsar PSR B7+12. These were the first confirmed exoplanets ever detected. But here is the twist. Pulsar planets are not planets in the traditional sense. They are the remnants of a destroyed solar system. When a massive star goes supernova, it obliterates everything around it. The neutron star that remains is a graveyard. Any planets that form afterward are born from the debris of the explosion. These planets are bathed in lethal radiation. They orbit in a region of space so hostile that nothing could live there. And yet, these dead worlds were the first exoplanets we confirmed. They are technically planets, but calling them planets feels wrong. They are monuments to destruction. That is lie number 28. All planets are created equal. They are not. Now let us get to lie number 29, the Neptunian desert. This is a region of parameter space where Neptune-sized planets are rare. Close to their stars, we find hot Jupiters and small rocky planets. But Neptune-sized planets in tight orbits are almost non-existent. Why? 2 competing explanations. One says Neptune-sized planets form but get their atmospheres stripped away, shrinking them to super-Earth size. The other says Neptune-sized planets in this region simply do not form in the first place. Recent discoveries are complicating the picture. A few Neptune-sized planets have been found in the desert, proving it is not completely empty. And the boundaries of the desert are fuzzy. It is not a sharp cutoff. It is a statistical trend. But the lie is that the Neptunian desert is well understood. It is not. Every new discovery forces astronomers to revise their models. The desert is real, but we do not know why it exists. That is lie number 29. Let me tell you about lie number 30. Planet formation is a solved problem. You hear astronomers talk confidently about how planets form. Gas and dust in a protoplanetary disk collide and stick together. Small grains grow into pebbles. Pebbles grow into planetesimals. Planetesimals grow into planets. This is called core accretion, and it is the standard model. Except it does not work for everything. Hot Jupiters do not fit the model. Circumbinary planets do not fit. Planets around pulsars do not fit. The radius gap does not fit. Sub-Neptunes do not fit. Every time we find a new class of planet, we have to add new mechanisms to the model. Migration, tidal interactions, gravitational instabilities, photoevaporation, pebble accretion. The list keeps growing. Planet formation is not one process. It is dozens of processes interacting in ways we're still trying to understand. And yet, textbooks and press releases talk about it, as if we have it figured out. We do not. That is lie number 30. Now we arrive at lie number 31. Astrobiology is about finding life. You would think that is obvious, but it is not entirely true. Astrobiology has become as much about understanding why life is absent as it is about finding it. Every barren planet, every stripped atmosphere, every radiation-blasted surface teaches us something about the limits of habitability. We have learned that red dwarf planets are probably uninhabitable. We have learned that tidal locking is not automatically fatal. We have learned that habitable zones are more complicated than we thought. We have learned that Earth might be an outlier. These are not failures, they are discoveries. The goal of astrobiology is not to confirm our biases, it is to understand the universe as it actually is. And if that universe is mostly empty, then that is the truth we need to accept. That is lie number 31. Astrobiology is just cheerleading for alien life. Let me tell you about lie number 32. When we find life, it will change everything. This is the big one, the ultimate hope. The discovery of extraterrestrial life will unite humanity, revolutionize science, reshape philosophy, and prove we are not alone. Maybe. Or maybe it will be a footnote. If we detect a biosignature on an exoplanet 40 light-years away, we cannot visit it. We cannot communicate with it. We cannot learn anything more than it exists. The discovery will spark debate. Some scientists will argue the signal is biological. Others will argue it is a false positive. The debate will rage for years, decades, centuries. Meanwhile, life on Earth will continue. Wars will be fought. Economies will rise and fall. People will be born and die. The existence of microbes on a distant planet will not change their daily lives. Do not misunderstand me. Finding life would be one of the greatest scientific achievements in history. But the idea that it will transform humanity overnight is naive. Change is slow, discovery is fast. That is lie number 32. And now we arrive at lie number 33, the final lie, the biggest lie of all. We're close to answering the question, are we alone? You hear this constantly. With the James Webb Space Telescope, with future missions like the Habitable Worlds Observatory, with ground-based extremely large telescopes, we're on the verge of finding life, any day now. Here is the truth. We're not close. We're barely at the starting line. We have confirmed over 6,000 exoplanets. Sounds impressive. But the Milky Way contains at least 100 billion stars. If even a small fraction of those stars have planets, we're talking about hundreds of billions of planets. We have sampled 0.0001% of them. And most of the planets we have found are not candidates for life. They are too hot, too big, too close to violent stars, or too far from us to study in detail. The truly Earth-like planets, the ones orbiting Sun-like stars at Earth-like distances, are almost invisible to our current instruments. We cannot detect their atmospheres. We cannot measure their compositions. We can barely confirm they exist. The James Webb Space Telescope is revolutionary, but it can only study a handful of targets in detail. Future missions will improve our capabilities, but we are talking about decades before we have the technology to comprehensively search for biosignatures. And even then, biosignatures might be ambiguous. We might spend centuries debating whether a signal is biological or geological. The question, are we alone, might not have a simple answer. It might not have an answer at all. That is lie number 33. The idea that we are close to solving the mystery. So where does this leave us? We have dismantled 33 of the most pervasive lies, misconceptions and oversimplifications in exoplanet science. Does this mean exoplanet research is worthless? Absolutely not. The discoveries are real, the science is groundbreaking, but the public narrative, the story told in press releases and headlines, is often disconnected from reality. Habitable zones are not habitable. Super-Earths are not Earth-like. TRAPPIST-1 is not a beacon of life. Biosignatures are not proof, and we are not close to answering the big questions. This does not diminish the importance of the work. If anything, it makes it more important. Every false positive teaches us to be more careful. Every failed detection refines our methods. Every disappointment brings us closer to understanding what is actually out there. The universe does not owe us alien life. It does not owe us habitable planets. It does not owe us easy answers. But if we keep looking, if we keep questioning, if we keep tearing down our assumptions and building better ones, maybe, just maybe, we will find something real. Or maybe we will find nothing, and that too would be an answer. The truth is out there, but it is buried under layers of hype, hope, and wishful thinking. It is time to dig through those layers and face reality. 33 lies exposed. The truth remains elusive, but at least now you know what you're up against. But we are not done yet. There are more layers to peel back, more lies to expose, because the 33 we have covered so far are just the beginning. The rabbit hole goes deeper. Let us continue. Here is something nobody talks about: the exoplanet confirmation bias. When a planet candidate is announced, the scientific community wants it to be real. Funding depends on discoveries. Careers are built on them. Papers are published about them. So there is pressure, subtle but real, to confirm rather than reject. This does not mean scientists are dishonest. It means they are human. And humans see what they want to see. Study after study in psychology has shown that confirmation bias affects everyone, including scientists. When analysing noisy data from a potential planetary transit, if you expect to see a planet, you're more likely to interpret ambiguous signals as planetary. If you expect stellar activity, you interpret the same signals differently. This is why independent confirmation is so critical. And yet, in the early days of exoplanet discovery, independent confirmation was often lacking. Planets were announced based on single data sets. When follow-up observations failed to confirm them, the original team sometimes doubled down rather than admit error. The exoplanet archive is filled with planets whose status changed from confirmed to candidate to false positive as new data came in. This is science working as intended. Self-correction. But it reveals something uncomfortable. How many of the currently confirmed planets will be downgraded in the future? We do not know, and that uncertainty should make us humble. Now let us talk about something that will upset a lot of people: the habitability hype cycle. Every few months, a new potentially habitable planet is announced. The press release emphasizes Earth-like qualities. News outlets pick up the story. Social media explodes. Then, a few months later, follow-up studies show the planet is not actually habitable. But those studies do not get press releases. They do not make headlines. The public remembers the excitement, not the retraction. This creates a false impression that we are constantly finding habitable worlds. We are not. We are constantly finding planets that might be habitable if you squint really hard and make a lot of optimistic assumptions. The habitability hype cycle serves a purpose. It keeps the public interested in exoplanet science. It justifies funding for telescopes and missions, but it also erodes trust. When people hear about the 10th Earth 2.0 in as many years, they start to tune out. They stop believing the hype, and when we actually do find something significant, they might not care anymore. The Boy Who Cried Wolf is not just a fairy tale, it is a warning. Let me tell you about something called the sub-Neptune crisis. Astronomers discovered that sub-Neptunes, planets between Earth and Neptune in size, are the most common type of planet in the galaxy. But we have no idea what they are made of. Are they rocky planets with thick hydrogen atmospheres? Are they water worlds? Are they gas dwarfs? The problem is that multiple compositions can produce the same observed radius and mass. A dense rocky planet with a thick atmosphere looks the same as a less dense water-rich planet with a thin atmosphere. Degeneracy. This is a technical term meaning we cannot uniquely determine the answer from the available data. Astronomers have proposed dozens of models to explain sub-Neptunes. Steam worlds, ocean planets, gas dwarfs, hybrid models. But we cannot test these models without better data, and getting better data requires observing time on the James Webb Space Telescope, which is oversubscribed by a factor of 10. The sub-Neptune crisis is not just an academic problem. If we cannot figure out what the most common type of planet is, how can we claim to understand planetary systems? This is a fundamental gap in our knowledge, and it is not getting the attention it deserves. Here is another uncomfortable truth. Metallicity might not matter as much as we think. For years, astronomers believed that high metallicity stars are more likely to have planets. This is true for giant planets. The correlation is strong, but for small rocky planets, the correlation is weak or non-existent. Studies have found Earth-sized planets around metal-poor stars. This suggests that the conditions required to form rocky planets are more universal than we thought. So why do we focus so much on metallicity? Because it is easy to measure. Stars have spectral lines that tell us their composition. We can determine metallicity from a single observation. But just because something is easy to measure does not mean it is important. We have optimized our search strategies around a parameter that might not actually be relevant to finding habitable worlds. This is the streetlight effect, looking for keys under the streetlight, because that is where the light is. not because that is where the keys are. Let us discuss something that sounds boring but is actually critical. Noise. Data from telescopes is noisy. Light from stars fluctuates. Instruments have systematic errors. Cosmic rays hit detectors. Atmospheric turbulence blurs images. All of this creates noise, and in that noise, patterns can emerge by pure chance. If you look at enough noisy data, you will eventually see something that looks like a planetary signal. This is called a spurious detection. The only way to avoid spurious detections is to set strict statistical thresholds. A signal must be strong enough that there is less than a 1 in 1,000 chance it is noise, or 1 in 10,000, or 1 in a million. But here is the problem. The stricter the threshold, the more real planets you miss. So astronomers have to balance false positives against false negatives. Miss too many real planets, and you slow discovery. Accept too many false positives, and you flood the literature with garbage. Different teams use different thresholds. This leads to inconsistencies. A planet confirmed by one team might not meet the standards of another. And when press releases announce discoveries, they do not mention the statistical nuances. They just say planet found. The public does not know that the confidence level might be only 95%. That 1 in 20 similar detections is probably noise. This is not lying, but it is not full transparency either. Now let us talk about exomoons. For years, astronomers have searched for moons around exoplanets. Moons are interesting because they could be habitable even if their planet is not. A moon around a gas giant in the habitable zone could have liquid water. Tidal heating from the planet could keep the moon warm. This is how Europa and Enceladus have subsurface oceans despite being far from the Sun. The problem is that detecting exomoons is incredibly hard. Moons are small, their gravitational effects are tiny, their transits are shallow. To date, there have been a few tentative exomoon candidates, but none confirmed. Every time a candidate is announced, follow-up observations fail to confirm it. The signal disappears or turns out to be something else. This does not mean exomoons do not exist. They almost certainly do, but finding them requires better instruments and longer observation times than we currently have. The hype around exomoons, the idea that they could be havens for life, is based on hope, not evidence. We do not even know if large moons are common around exoplanets. Our solar system has several large moons, but we might be unusual. Until we actually detect exomoons, all the speculation is just that, speculation. Let me tell you about the snowball Earth problem. Earth went through several periods in its history where it was almost entirely covered in ice. These snowball Earth events nearly wiped out life. If they had lasted longer, life might not have recovered. Now consider an exoplanet in the outer part of the habitable zone. It receives less radiation from its star, so it is prone to freezing. If it enters a snowball state, can it recover? On Earth, volcanic outgassing eventually released enough carbon dioxide to create a greenhouse effect that melted the ice. But this only worked because Earth has active plate tectonics and volcanism. A planet without these processes might stay frozen forever. Recent models suggest that some planets near the outer edge of the habitable zone could be permanent snowballs. Frozen worlds that technically sit in the habitable zone but are completely uninhabitable. This is another example of how the habitable zone concept fails. A planet can be in the zone and still be dead. The universe does not care about our definitions. Here is something that might surprise you. Planets can be ejected from their star systems. Gravitational interactions between planets can lead to instabilities. One planet gets flung out into interstellar space. It becomes a rogue planet, wandering the galaxy alone. Computer simulations suggest that for every planetary system that remains stable, at least one planet gets ejected. This means there could be as many rogue planets as there are bound planets. Billions of orphaned worlds drifting through the darkness. Most of them would be cold, dead, but some could have thick atmospheres that trap internal heat. Some could have moons with tidal heating. Some could have subsurface oceans. The idea of life on rogue planets is tantalizing, but it is also highly speculative. We have found very few rogue planets, and detecting biosignatures on a world with no star would be nearly impossible. Still, the possibility exists, and it reminds us that habitability might not require a star at all. The universe is stranger than we imagine. Now let us talk about planetary migration and its consequences. We know that planets move. They do not stay where they form. Hot Jupiters migrate inward. Some planets migrate outward. This migration can wreak havoc on planetary systems. A migrating giant planet can eject smaller planets. It can destabilize orbits. It can cause collisions. In our solar system, Jupiter may have migrated early in its history, a process called the Grand Tack hypothesis. This migration cleared out the inner solar system and prevented a super-Earth from forming where the asteroid belt is now. If Jupiter had not migrated, our solar system might look completely different. Earth might not exist, or it might be one of several Earth-sized planets. The point is that migration is chaotic. It shapes planetary systems in unpredictable ways. And when we look at other star systems, we see the aftermath of migration, but we do not see the process itself. We are trying to reconstruct a crime scene without knowing what the crime was. This makes it incredibly hard to predict which systems might have habitable planets. Migration could create habitable zones, or it could destroy them. We just do not know. Let me tell you about a concept called planetary habitability windows. A planet might be habitable for only part of its history. Early in its life, it might be too hot, bombarded by asteroids, with no stable surface. Later, as the star ages and brightens, the planet might leave the habitable zone and become too hot. Or if the planet loses its atmosphere or magnetic field, it becomes uninhabitable, even if it stays in the zone. The habitability window for Earth has been open for billions of years, but for some planets, the window might be only a few 100 million years. If life takes 1 billion years to get started, those planets will never host life, even if they are technically habitable for part of their existence. When we search for biosignatures, we are searching for planets where the habitability window is currently open. But we might be looking at planets where the window closed 1 billion years ago, or planets where it will not open for another 1 billion years. Timing matters, and we have no way to know the timing from our observations. Here is something that frustrates astronomers, but rarely gets discussed. Publication bias. Positive results get published, negative results do not. If a team searches for planets around a star and finds nothing, that result is hard to publish. Journals want discoveries, not non-detections. This creates a biased scientific literature. We know about all the stars with planets. We do not know about all the stars without planets. This skews our understanding of how common planets really are. Some stars might genuinely lack planets. Maybe they formed in environments where planet formation was disrupted. Maybe their protoplanetary disks dispersed too quickly. We do not know because non-detections do not make it into the literature. Recently, some astronomers have pushed for publishing null results. These papers are valuable because they tell us where planets are not, but they are still rare. The publication bias remains strong, and it distorts our picture of the universe. Let us discuss one more thing, the assumption of uniformity. When we model planetary systems, we assume that the laws of physics are the same everywhere. This is a reasonable assumption. But we also assume that the conditions for planet formation are similar across the galaxy. That might not be true. Different regions of the galaxy have different metallicities, different stellar densities, different radiation environments. Planets forming near the galactic center face different conditions than planets forming in the galactic outskirts. Planets forming in globular clusters face different conditions than planets forming in the galactic disk. We have only studied a tiny region of the galaxy, mostly nearby stars within a few thousand light-years. We have no idea if planet formation works the same way in distant regions. We assume uniformity because it makes the models easier, but the universe does not care about our convenience. Planets in different environments might be fundamentally different from what we have found so far, and we will not know until we look. Now let us bring this to a close. We have covered far more than 33 lies. We have exposed the cracks in the foundation of exoplanet science, the biases, the assumptions, the limitations, the hype. Does this mean we should stop searching? Absolutely not. It means we should search smarter. We should be more careful with our language. We should stop calling every new discovery Earth-like. We should stop claiming we are on the verge of finding life when we are not. We should be honest about what we know and what we do not know. Science thrives on skepticism. It thrives on questioning assumptions. It thrives on admitting when we are wrong. The exoplanet field has grown explosively over the past 3 decades. We have gone from 0 confirmed exoplanets to over 6,000. That is an incredible achievement. But growth brings growing pains. The field is still young. The tools are still being developed. The theories are still being tested. And that is okay. Science is a process, not a destination. So what is the takeaway? The truth is messy. Exoplanets are not the Earth-like paradises we hoped for. Habitable zones are not guarantees of habitability. Biosignatures might be false alarms. And we're not close to answering the big question. But that does not make the search any less important. Every planet we find teaches us something. Every failed detection refines our methods. Every surprise forces us to rethink our assumptions. The universe is vast and strange and indifferent to our desires. But it is real. And if we keep looking, if we keep questioning, if we keep pushing forward despite the setbacks and disappointments, we might just find something that changes everything. Or we might find nothing, and that too would be an answer. The search continues. The truth is out there. And now you know what stands between us and that truth. 33 lies, and countless more waiting to be uncovered. But before we end, let me leave you with one final thought. The biggest lie of all might be the one we tell ourselves, that finding life elsewhere will validate our existence, that it will give meaning to our place in the cosmos, that it will answer the questions we have been asking since we first looked up at the stars. Here is the truth. Finding life will not change who we are. It will not solve our problems. It will not make us wiser or kinder or more united. It will simply be a data point, an observation, a fact about the universe. And maybe that is enough. Maybe the search itself is the point, not the destination, but the journey. Every telescope we build, every planet we discover, every false positive we identify, brings us closer to understanding the universe as it actually is, not as we wish it to be. That is the real goal. Not to confirm our biases, not to satisfy our longing for cosmic companionship, but to see clearly, to think honestly, to accept reality on its own terms. And if that reality includes life elsewhere, wonderful. We will study it. We will learn from it. We will add it to our growing catalogue of cosmic wonders. And if that reality is one where Earth is unique, where life arose only once in a vast and empty universe, then that too is wonderful. Because it means we are witnesses to something impossibly rare, something precious beyond measure. Either way, the search continues, and now, armed with the knowledge of these 33 lies and all the deceptions that surround exoplanet science, you can watch that search with clearer eyes. You can separate hype from reality. You can ask the hard questions. You can demand better. Because the truth matters, not the comfortable lies we tell ourselves. Not the wishful thinking that masquerades as science, but the actual, uncomfortable, messy truth. That is what we are searching for, and that is what you now know to look for too. The universe does not owe us easy answers, but it does offer honest ones to those willing to look past the lies. Keep searching, keep questioning, keep demanding the truth. The cosmos is waiting, and so is reality. Thank you for watching. This is The Calm Scientist.